Hey everyone, the chapter that we are starting today is the chapter of polygons. Truth be told, this is the easiest chapter of geometry. So let's get started. In today's class, we'll start with the basic definition of what a polygon is. Then we'll discuss the types of polygons. Eventually, we'll also discuss the concept of interior angle, exterior angle, as well as diagonals of a polygon. And then we'll end today's class with some discussion on hexagon and octagons. What's a polygon? Let us understand the definition of a polygon using a very simple example. मैंने यहाँ पे 7 फिगर्स क्रिएट किए हैं. एज पर योर नॉलेज ये 7 फिगर्स में से कौन कौन से फिगर्स पॉलीगन्स हैं और कौन से नहीं हैं. जस्ट थिंक अबाउट इट. A common understanding, although wrong, but a common understanding which many students have is that ये triangle है, ये square है, तो ये pentagon, hexagon, ये वाले polygons हैं, but ये तो triangle और square है, ये polygons नहीं है. That is a wrong understanding of the concept. By definition, a polygon is defined as an n-sided closed figure. Now, what do I mean when I say it's a n-sided closed figure? It simply means that मेरे पास n line segments हैं जो आपस में एक closed figure बनाते हैं. By this definition, a triangle is a polygon. You have got 3 sides and they are creating a closed figure. A square is a polygon. You have got 4 sides and they are creating a closed figure. Remember, any n-sided closed figure, whether it's a triangle or a square or a quadrilateral or a pentagon or a hexagon, is a polygon. By definition, a polygon is an n-sided closed figure. n का वैल्यू कुछ भी हो सकता है. It can be 10, it can be 20, it can be 2000. You can have a 2000-sided closed figure and yet it would be a polygon. However, on the lower side, the number of sides is a minimum of 3. अगर हम नंबर ऑफ साइड्स को 3 से कम करने का कोशिश करते हैं तो पॉलीगन नहीं बन सकता. अगर हम 2 साइड्स के साथ एक फिगर कंस्ट्रक्ट करने का कोशिश करें, एट इट्स बेस्ट इट वुड बी एन एंगल, बट इट वुड नेवर बी अ पॉलीगन. So for a polygon to exist, you need to have n sides which are creating a closed figure and the minimum value of n has to be 3. That means number of sides को minimum अगर मुझे रखना है तो वहां पे जो polygon बनेगा that would be triangle. You go on increasing the number of sides and every time you would be getting a polygon. So up to this point we have defined the basic definition of a polygon. A polygon is an n-sided closed figure. So ये चीज तो sure है कि first, second, third and fourth ये 4 figures polygons हैं. What about this figure and this figure? Are these polygons? Well, by definition a polygon is an n-sided closed figure. Do we have n sides here? Yes, I've got 1, 2, 3, 4. I've got 4 sides here. So it's a 4-sided figure. Is it closed? Yes, it is closed. So a polygon is defined as n-sided closed figure. So by this definition, even this is a polygon. Even this is a polygon. In fact, all these figures are polygons by the definition of n-sided closed figure. Obviously, it's a common sense rule to understand that all the n sides and all the n vertices so created are on the same plane. A polygon has to be on the same plane. All the 4 sides or all the 5 sides or all the n sides of a polygon need to be on the same plane. What is the difference between this set of polygons and this set of polygons? Well, if you consider these 4 polygons, none of the interior angles is greater than 180 degree. Such a polygon is called as a convex polygon. एक कॉन्वेक्स पॉलीगन वो है जिसमें कोई भी इंटीरियर एंगल 180 डिग्री से बड़ा नहीं है. ऑन द अदर हैंड, अगर एक भी इंटीरियर एंगल, एक या एक से ज्यादा, अगर एक भी इंटीरियर एंगल 180 डिग्री से बड़ा हो जाए, वी कॉल दैट एज अ कॉन्केव पॉलीगन. So what's the basic difference between these kind of polygons and these kind of polygons? In the first category of polygons, all the interior angles are less than 180. लेकिन concave polygons में there is at least one angle, at least one interior angle which is greater than 180. What about this figure? Is this a polygon? Yes, it's a polygon because you have got n sides and these n sides are creating a closed figure. However, unlike the other polygons, in this polygon, some of the sides are intersecting among themselves. इस तरीके के फिगर को जहां पे कुछ साइड्स आपस में इंटरसेक्ट करती है, we call it as a self intersecting polygon. Luckily, as far as your paper is concerned, आपको ना तो सेल्फ इंटरसेक्टिंग पॉलीगन्स में जाना है, ना ही आपको कॉन्केव और कॉन्वेक्स की डिफरेंशिएशन में जाना है. The only kind of polygons you need to be concerned about are the regular polygons. A regular polygon is a polygon in which all the sides are equal. For example, consider this regular hexagon. Hexagon has 6 sides, and if it's a regular hexagon, all the 6 sides are equal. Now what happens when I say all the 6 sides are equal? Well, if all the 6 sides are equal, all the 6 interior angles end up becoming equal as well. Also, since all the sides are equal, there's a sense of symmetry in the figure. Now, what do I mean when I say that there's a sense of symmetry in the figure? Well, what I simply mean is that अगर इस hexagon में मैं एक line of symmetry draw करूं, तो ये line of symmetry इस hexagon को दो equal parts में divide करेगी. So इस line of symmetry के left पे जितना hexagon होगा, exactly उतना hexagon line of symmetry के right side पे होगा. So as far as regular polygons are concerned, we need to remember 3 things. Number 1, all their sides are equal. Number 2, all their interior angles are equal. And number 3, they have symmetry in them. Apart from these 3 points, there's nothing much that you need to know about regular polygons. As far as your syllabus is concerned, we will be only dealing with regular polygons. So concave polygons, convex polygons, इन सब polygons के discussion में हमें नहीं जाना. The only questions that you will see will be questions based upon regular polygons. Next, what we have is the concept of interior angle and exterior angle of a regular polygon. Consider a regular pentagon. By the way, the concept that I am explaining here is not just valid for a pentagon, it is also valid for a hexagon, septagon, octagon. In fact, ये जो concept हम यहाँ पे discuss करने जा रहे हैं, ये किसी भी regular polygon के लिए valid है. Let us say the pentagon under consideration has been labeled as A, B, C, D, E. Now for this regular pentagon, I am supposed to find this exterior angle X. What should I do? Well, first of all, let us understand that the exterior angle and the interior angle form a linear pair. If I consider the interior angle C and I consider the exterior angle X, these two angles form a linear pair. That means इनका sum 180 degree है. Also, in our previous discussion, we learned that for all regular polygons, interior angles are equal. So किसी भी regular polygon के लिए जो interior angles होते हैं वो equal होते हैं. If I am considering this regular pentagon, तो यहाँ पे जो interior angle A, interior angle B, C, D and E, ये जो 5 angles हैं, ये पांचों interior angles आपस में equal होंगे. Also, क्योंकि exterior angle और interior angle आपस में supplementary हैं, आपस में linear pair बनाते हैं, तो can I say अगर पांचों interior angles equal हैं, तो as a result पांचों exterior angles भी equal होंगे. Now what does that mean? It simply means that if exterior angle C has been labeled as X, I can extend CB and mark the exterior angle B as X. Exterior angle A can also be marked as X. Exterior angle E can also be marked as X. And of course exterior angle D can also be marked as X. What we have here is a situation जहाँ पे एक regular pentagon के 5 exterior angles हैं और वो पांचों ही equal हैं. मुझे x का वैल्यू निकालना है. Let us consider the side DC. मैंने side DC को point C पे रख के x डिग्री से रोटेट किया. If I consider my side DC and I place my side DC onto point C and rotate it by x degree, what I get is side BC. अगेन मैंने साइड BC को पॉइंट B पे रख के x डिग्री से रोटेट किया, मेरे पास साइड AB बन जाएगा। मैंने साइड AB को पॉइंट A पे रख के x डिग्री से रोटेट किया, व्हाट आई एम गोना गेट इज साइड AE। एंड फाइनली अगर मैं साइड AE को दोबारा x डिग्री से रोटेट करूं, मेरे पास साइड ED बन जाएगा। एंड फॉर द फिफ्थ टाइम अगर मैं साइड ED को पॉइंट D पे रख के वापस x डिग्री से रोटेट करूं, आई एम गोना गेट द ओरिजिनल साइड DC अगेन। What's happening here? What's happening here is that your side DC is taking, or it's rather covering, a complete angle of 360 degree. So can I say in 5 steps, side DC has covered a total angle of 360 degree. Now since this 360 degree, this total angle of 360 degree has been covered in 5 steps, 5 equal steps of x degree each. From here, I can say that 5x equals 360 degree, or perhaps x equals 360 by 5. Now what was x? X was my exterior angle. And what was 5? What was 5? Well, for a pentagon, 5 represents the number of sides. So from here, can I say exterior angle is 360 by n, where n represents the total number of sides. As I mentioned earlier, this concept is not just valid for a pentagon, it is also valid for all the other regular polygons as well. We just learned that interior angle and exterior angle form a supplementary pair. So अगर मैं exterior angle का फॉर्मूला निकाल चुका हूँ, इस फॉर्मूला को यूज करके मैं interior angle का फॉर्मूला भी बना सकता हूँ. Can I say interior angle is nothing but the supplementary of exterior angle, or perhaps can I say interior angle is 180 degree minus 360 by n? These two formulas represent the formula for exterior angle and interior angle for any n-sided polygon. Another way of deducing the formula for interior angle and exterior angle of a regular polygon is to work upon the sum of interior angles of a polygon. Let us consider a pentagon again. Let us say मुझे इस pentagon के 5 angles का sum निकालना है. So I have to find the sum of all interior angles of this pentagon. Well, if I have to find the sum of all interior angles of a pentagon, an easy way of finding the sum of all interior angles would be to divide this pentagon into 3 triangles. As we know, sum of interior angles of one triangle is 180 degree. So if a pentagon can be expressed as sum of 3 triangles, I can say that the sum of interior angles of a pentagon has to be 3 times 180, or perhaps 540 degree. So what I've done here is that I've considered my pentagon as sum of 3 triangles. And if a pentagon is sum of 3 triangles, then the sum of all interior angles of pentagon has to be 3 times 180. In a similar fashion, I can consider a hexagon. A hexagon can be divided into 4 triangles. Each triangle has sum of angles as 180. So can I say the total sum of interior angles of a hexagon has to be 4 times 180, or perhaps 720 degree. Consider an octagon. Can I divide an octagon into 6 triangles? Yes, I can. What happens when I divide an octagon into 6 triangles? Well, if I divide an octagon into 6 triangles, each triangle has sum of the angles as 180. So the total sum of interior angles of an octagon ends up becoming 6 times 180. Hopefully, we are able to follow the logic here. What I'm trying to understand here, or what I'm trying to make you people understand here, is that any polygon can be divided into triangles. So a pentagon, which is a 5-sided polygon, got divided into 3 triangles. A hexagon, which is a 6-sided polygon, got divided into 4 triangles. An octagon, which is an 8-sided polygon, got divided into 6 triangles. Any n-sided polygon can be divided into n minus 2 triangles. So if I have an n-sided polygon, then that n-sided polygon can be divided into n minus 2 triangles. Since the sum of interior angles of each triangle is 180, For n minus 2 triangles, the sum of interior angles has to be n minus 2 into 180. That's my formula for sum of interior angles of an n-sided polygon. Hopefully we are able to follow this logic. Using this logic, I can find out the sum of interior angles of any n-sided polygon. For any n-sided polygon, the sum of all interior angles has to be n minus 2 into 180 degree. So what we have here is the formula for sum of interior angles of an n-sided polygon. हमने पिछले डिस्कशन में ये डिड्यूस किया है कि हम किसी भी n-sided polygon को n-2 triangles में रिप्रेजेंट कर सकते हैं, and as a result sum of interior angles of such n-sided polygon will always be n-2 into 180. Well, अगर हम एक n-sided polygon को कंसिडर करें तो n-sided polygon के लिए सम ऑफ एंगल्स ये है, और क्योंकि एक रेगुलर पॉलीगन है ये सारे के सारे n एंगल्स आपस में इक्वल होने वाले हैं, तो कहना है इसे अगर n एंगल्स का सम ये है तो एक इंटीरियर एंगल विल बी नथिंग बट सम ऑफ द एंगल्स बाय n. Now this thing can be further simplified. I can take this 180 and multiply that with n. So 180 times n minus 2 times 180, which is 360. This entire thing gets divided with n. So what I have here in the form of an interior angle is nothing but 180 degree minus 360 by n. That's another way of defining the interior angle for a given regular polygon. Hopefully we are able to understand this basic logic here. Next, we move on to the logic of diagonals of a regular polygon. Consider a regular hexagon ABCDEF. Calculate the total number of diagonals of this regular hexagon. A common but wrong answer which pops up at this moment is that the total number of diagonals are 3. So what students do is that they end up calculating or counting diagonal AD, EB and FC. So वो diagonal AD को, EB को और FC को count करते हैं and they pop up 3 as the answer, that this hexagon has 3 diagonals. Well, that is incorrect. Why? Because by definition a diagonal is a line segment which joins a given vertex with any of the opposite vertices. So अगर मैं diagonal A से ड्रॉ करना चाहता हूं तो A से D को ज्वाइन करने वाला लाइन सेगमेंट तो डायगोनल है ही, बट इसके अलावा AC एंड AE भी डायगोनल है. सो व्हाट आई एम सेइंग हियर इज दैट diagonal AD is for sure a diagonal, but diagonal AC is also diagonal and diagonal AE is also diagonal. So what we have here is a situation where from vertex A we have got 3 diagonals. So calculate the total number of diagonals for this hexagon. The next answer which pops up here is that there are a total of 18 diagonals. Now what's the logic here? The logic here is that from vertex A I can draw 3 diagonals and such 6 vertices exist. So अगर हर vertex से 3 diagonals बनाए जा सकते हैं और मेरे पास ऐसे 6 vertices हैं, तो total number of diagonals that I can draw are 18. This is also wrong. Why is this wrong? Because when I'm calculating the total number of diagonals as 3 into 6, 18, what I'm doing here is the double counting of diagonals. Let me explain. जब मैंने vertex A से diagonal AD को count किया और उसके बाद vertex D से diagonal AD को count किया, तो मैंने same diagonal को 2 बार count कर लिया. What happens here is that I end up calculating or end up counting every diagonal twice. So in order to nullify this double counting of diagonals, what I need to do is that I need to divide the total number of diagonals so obtained with 2. So 9 has to be my final answer. So for this hexagon, the total number of diagonals that I can draw are 9. 3 diagonals from each vertex, a total of 6 vertices gets me a total of 18 diagonals, But since these 18 diagonals, in each of these 18 diagonals, I am considering double counting. So I divide that 18 with 2 and get my final answer as 9. So there are 9 unique diagonals which are possible for this hexagon. Hopefully we are able to understand this logic. Now let us further generalize this logic. Instead of considering a 6-sided figure, or instead of considering a hexagon, let us consider a journal n-sided polygon. It's an obvious common sense rule to understand that for an n-sided polygon, there will be n vertices. From each vertex, I can draw a diagonal to any of the opposite vertices, but I cannot draw a diagonal to the vertex which is to the immediate left or to the immediate right. So मैं हर vertex से सामने वाले सारे vertices के ऊपर diagonal बना सकता हूँ. मैं किसके ऊपर diagonal नहीं बना सकता? मैं उस vertex के immediate left और immediate right वाले दो vertices पे diagonal नहीं बना सकता. Also, given vertex से उसके ऊपर वापस diagonal नहीं बन सकती. That means अगर मैं एक n-sided figure को consider करूँ जिसमें n vertices हैं, तो उसमें हर वर्टेक्स में n-3 डायगोनल जनरेट होंगी. वो अपने इमीडिएट लेफ्ट, अपने इमीडिएट राइट और अपने ऊपर इन 3 वर्टिसेस के अलावा बाकी के रिमेनिंग n-3 वर्टिसेस के ऊपर एक एक डायगोनल कंस्ट्रक्ट करेगा. एंड सिंस ये n-साइडेड फिगर है, यहाँ पे n वर्टिसेस, अ टोटल ऑफ n इंटू n-3 डायगोनल्स देंगे. अब क्योंकि सभी की डबल काउंटिंग हो रही है, देयरफॉर वी डिवाइड दिस विद 2. So number of diagonals for an n-sided polygon is given by the formula n into n-3 by 2. Hopefully we are able to understand the concept of diagonals here. Next we move on to practice questions of polygons.